Welcome back. In this module, we talk about the CIA Triad. CIA meaning confidentiality, integrity, and availability as a security framework. When cybersecurity is discussed, it is often framed in terms of incidents like breaches, leaks, outages, ransomware, and fraud. These events can feel chaotic and disconnected, one failure following another, each with its own explanation and fallout. To make sense of this complexity, cybersecurity relies on a simple but enduring conceptual model known as the CIA Triad. The CIA Triad stands for confidentiality, integrity, and availability. These three principles describe what it actually means for data and systems to be secure. Almost every security control, policy decision, and incident response can be traced back to protecting or failing to protect one or more of these elements. This section introduces the CIA triad not as an abstract theory, but as a practical lens for understanding cyber risk across any industry, role, or technology. Why cybersecurity needs a framework? Without a framework, cybersecurity becomes reactive. An incident occurs, a control is added, another incident follows, another rule appears, and over time, defenses accumulate. Without coherence, priorities blur, and risk decisions become inconsistent. The CIA triad provides structure. It offers a shared language that allows people with very different backgrounds, technical teams, legal advisors, risk managers, executives, to discuss security using the same concepts. It helps distinguish between different kinds of failure and clarifies why not all cyber incidents are the same. Most importantly, it explains what security is trying to protect, not how to implement it. Confidentiality, controlling who can see information. Confidentiality is about ensuring that information is accessible only to those who are authorized to see it. When confidentiality fails, information is exposed to the wrong people. This exposure may be intentional, accidental, or indirect. Common examples include data breaches, unauthorized access, accidental sharing, information leakage, or eavesdropping. These are often the incidents that receive the most attention because they involve visible loss of control over sensitive information. But confidentiality is frequently misunderstood. Confidentiality is about control, not secrecy. A common misconception is that confidentiality means hiding information. In reality, most data exists to be used. It must be accessed, shared, processed, and analyzed to create value. Confidentiality ensures that this access happens deliberately and appropriately. Too much restriction can paralyze operations. Too little restriction creates exposure. Effective confidentiality is about balance, controlling access without preventing legitimate use. This is why confidentiality relies on mechanisms such as authentication, authorization, encryption, and monitoring working together rather than in isolation. How confidentiality typically fails. Confidentiality failures often occur not because controls are absent, but because they are misaligned with reality. Examples include credentials reused across systems, excessive access permissions, misconfigured cloud storage, data shared through informal tools, or over reliance on perimeter controls. In many cases, the data was never meant to be secret, it was meant to be controlled. When control breaks down, confidentiality follows. Integrity, trusting that information is accurate. Integrity refers to the accuracy and completeness of information. When integrity is compromised, data is altered, intentionally or unintentionally, in ways that make it unreliable. Examples include unauthorized modification of records, data tampering, corruption during processing, manipulation of logs, injection of false information. Integrity failures are often less visible than confidentiality breaches, but they can be just as damaging, sometimes more so. Why integrity is often underestimated. People tend to assume that if data has not been stolen, it is safe. This assumption is dangerous. Decisions based on incorrect data can lead to financial loss, regulatory violations, safety risks, and erosion of trust. In many contexts, using corrupted or manipulated data is worse than having no data at all. Integrity is what allows data to be trusted. Without integrity, analysis, automation, and decision making collapse. Integrity failures are not always attacks. Not all integrity failures are malicious. They can arise from software bugs, configuration errors, synchronization issues, system failures, human mistakes, and from a cybersecurity perspective, intent matters less than outcome. If data cannot be relied upon, the system has failed in its purpose, regardless of why the failure occurred. This is why integrity is a core security concern, not just a quality issue. How integrity is protected? Integrity is protected through mechanisms designed to prevent unauthorized change or detect it when it occurs. These include hashes and checksums, digital signatures, access controls, version control systems, audit logs, and validation rules. Detection is as important as prevention. Knowing that data has been altered and when is often more critical than stopping every possible modification. Availability, ensuring systems work when needed. Availability refers to ensuring that systems and data are accessible when they are needed. When availability fails, services become slow, unreliable, or entirely unavailable. Common examples include system outages, denial of service attacks, infrastructure failures, ransomware incidents, capacity exhaustion, and availability failures are often the most visible and immediately disruptive form of cyber incidents. Availability is about reliability, not just uptime. Availability is frequently reduced to uptime metrics, percentages that suggest precision and control. But availability is experiential. From a user's perspective, a system either works or it does not. A service that is technically up but unusable in practice is not available in any meaningful sense. Availability includes performance, resilience, scalability, and recoverability. It is about continuity, not perfection. Designing for failure. Unlike confidentiality and integrity, availability often assumes failure will occur. Hardware breaks, networks fail, software crashes, and attacks happen. Availability depends on how systems respond when something goes wrong. This is why availability relies on redundancy, backups, monitoring, incident response, and disaster recovery planning. Availability is not achieved by avoiding failure, it is achieved by surviving it. The inevitable trade offs. One of the most important insights of the CIA Triad is that its elements often conflict. Increasing confidentiality may reduce availability. Strengthening integrity controls may slow systems. Improving availability may require broader access. These trade offs are unavoidable. Cybersecurity decisions are rarely about maximizing all three simultaneously. They are about prioritization based on context, risk tolerance, and impact. Understanding this helps explain why security decisions differ across systems and environments and why there is no single correct configuration. Why incidents feel so different. The CIA Triad explains why cyber incidents vary so widely in nature and consequence. A data breach is primarily a confidentiality failure. A ransomware attack often targets availability. Data manipulation attacks undermine integrity. Many incidents involve multiple elements at once. This perspective prevents oversimplification. Not all cyber incidents should be treated or discussed in the same way. The CIA Triad as a descriptive model. The CIA Triad does not prescribe specific controls. It does not tell you how to secure systems. It tells you what must be protected. This makes it flexible across technologies, industries, organizational sizes, and regulatory environments. Its value lies in clarity, not complexity. Why the CIA Triad still matters in the AI age. Despite rapid technological change, the CIA Triad remains relevant. AI systems still rely on data. They still require access controls. They still depend on availability. They're still vulnerable to manipulation. In fact, AI often amplifies CIA risks. Confidential data may be used for training. Integrity of models become critical. Availability of automated systems becomes essential. The fundamentals do not disappear, they intensify. The human dimension of the CIA triad. Confidentiality protects privacy. Integrity protects trust. Availability protects continuity. Failures in any of these dimensions have human consequences, which are financial, emotional, operational, and societal. Recognizing this reframes cybersecurity as a responsibility, not just a technical function. So, the key takeaway is that the CIA triad provides a clear and enduring framework for understanding cybersecurity. It explains what security is trying to protect and why different failures matter in different ways. Once you internalize this model, cyber incidents stop feeling random. They become understandable and comparable. This framework will anchor everything that follows in this module and beyond.